So,
That's not recorded?
so sorry, you're going to have to do that all over again now. So there's our soil A. So let's go through soil B. And those of you who figured out how to annotate, you can actually draw on the screen as well. I'm going to clear out my drawings. But if someone would like to demonstrate soil B using the annotation feature, and if you want to, you go up to View Options, and then you can click on Annotate. Just go ahead and start to show where that's going to intersect. That's productive.
Playing a mess.
Well, someone figured out how to use the Annotate feature, that's for sure.
Yes.
Looking good. We got 30% silt. We're going along that line. We got 40% sand. I feel like play-by-play announcer. And he's coming through. Or she. Making a line. Very close. And it looks like we've got an intersection at Clay Loam. That's right, folks. Clay Loam.
Now, out of curiosity, does 30 plus 40 plus 60 equal 100? Yes, thank you guys. So this line.
Yeah, so where's that clay? Where's that clay line?
Franklin.
Franklin, no. No. Franklin.
There it is. There it is. With the assist, I'm assuming. Right? So here's our intersection. There's our intersection. Excellent. We've got 30% clay, 30% silt, 40% sand.
Franklin, no.
Clay loam. Awesome. All right.
Sorry, my dog gets really excited about clay loam.
Clearly. All right, and I'm gonna erase everything. Thank you so much. I'm gonna erase everything. Someone else chime in for soil C. 60% sand, 30% clay. You got this.
Can anyone even just tell us where would we start? What's the first thing that we could circle? Of course. Can anyone just circle on the triangle? Can anyone circle 60% sand?
That is correct. There we go. Okay. So 60% sand, is that going to go up and to the left or up and to the right? Good. 30% goes straight across from the clay because the clay. Oh, fantastic. Look at that.
Woo.
That's a home run. So soil C is in fact sandy clay loam. Beautiful. So that's how we use this soil texture triangle to determine the texture of a particular soil. And what we're going to do today is we're going to, yes, Woot is correct. What we are going to do today is we're going to look at our soils that we collected or didn't collect. I understand that we all have limited resources right now, and also limited energy and time. So if you were able to collect some soils, that's fantastic. If for whatever reason you are unable to collect some soils, you can follow along with what other people did, including me, in order to get some data so that you can answer the questions, so you can get a good idea of how we can actually determine soil texture given this actually really simple and straightforward lab. And if you're like, you know what, I didn't do it, but it's something that I can totally do today now that the weather's warming up a little bit. I can go outside and get a soil sample, and I can do this before Sunday, because you can totally do it. It only takes 24 hours. And then you'll see the measurements are really straightforward, especially if you mix up your soil well. So let's get to that. Oops, I need to actually stop drawing. We had a great yoga session on Wednesday. We are going to have another yoga session next Wednesday in the morning. It is a great way to start hump day. And really, you know, I know I feel so stretched out, so relaxed after the yoga session. So please come join us, and tell other folks to come join us. I know some of you don't like getting up too early in the morning, but it's good to keep to a good schedule, regular schedule, not waking up at 2 in the afternoon.
It's so worth it. It really is worth it.
So first of all, I have a reminder on there to thank everyone for being here, because I don't say that enough. I know Mr. Tout does, but really thank you for being here, for putting forth all your effort to get this work done. It means a lot. You are reaping the rewards of this, because for a variety of reasons, this is keeping you on a regular schedule. You're learning so much about this subject. And even though, we're at this weird time and this weird space of just kind of like, we're finishing up with the school year and who knows what all this means, this really sets the stage for you, for your continued learning. And I just want to thank you for making all the efforts that you're making. Even if you're listening to this later and you're not here right now, it still makes a big difference that you're making these efforts. And I know a lot of you do catch up on the videos. So the soil lab is what we're going to finish. And then if we have extra time, which given all the tangents we keep going on, probably won't have, but I want to make sure that you know how to do the soil lab, even with the materials that you have at home.
Oh, Mr. Dutton, can I actually say something?
Yeah, of course.
About the soil lab. So I guess I want to say this because I've had a few students email me about grades and what's going on, and we don't have definitive answers for you like this is definitely what's happening with everyone, but I can tell you, like for instance, with this lab, even if you weren't able to collect soil, like we're going to talk about some data together on this video right now. And then you guys can take that data and write up a lab report, right? In terms of how that's graded. Mr. Dutton or I, one of the two of us will grade it, but the only thing that can do is help your grade. So because this is all on Zoom, this is an opportunity for you to boost your third quarter grade. And so I've been urging my sophomores especially, but you guys as well, definitely take advantage of these opportunities, because I know I've also had several conversations with people who are like, I'm not happy with my third quarter grade, what do I do? And my first recommendation is like, take advantage of, like you're here, we're gonna start this lab report together. You can talk to one another, get advice. You can ask Mr. Dutton or myself questions about it, get this lab report in, and you can pretty much rest assured that Mr. Dutton and I are grading a little bit more leniently right now, than we would be in normal circumstances, because we know you guys have less access to us. You have less access to actually getting your hands on the materials. So just putting in the effort, putting in what I would call a good faith effort, trying each part of the lab report, reaching out to us with some questions, that's going to boost your grade. And like the lab report percentage of your grade, I think is 20%.
Yeah.
So, you know, that's a big piece of it that you can improve your grade from the third quarter. So you guys are really doing the right thing by just being here and following through with the assignments you're turning in via Google Classroom. So definitely keep it up. Or if you've been following along but not turning things in, go back, turn stuff in. We're really happy to see it come in. We're really happy to give you credit for it and put that stuff in ManageBack, but it really does sort of act as effectively as bonus grades, right? Or opportunities to boost your grades. So please continue to take advantage of that and continue to ask questions. I'm getting lots of emails and lots of messages with questions, and I really appreciate that you guys are asking and thinking about these things. So keep it up. Are you set, Mr. Dutton? Ooh. What's better than 2 Mr. Duttons to wake you up in the morning?
Almost anything, really. Okay, let's not. All right, forgot to mute. All right, so I think I'm all set to demonstrate what I did here. So this is what it looked like when I first collected it and mixed everything up. And I'm looking right now at the presentation that's attached to in Google Classroom to this assignment. And this is what it looked like after 24 hours, actually what it looks like now. And so you can see very clearly the layers that have been created essentially by the settling of all this. It depends on lighting, and that's why I've got my setup over here on the side. I'm trying to demonstrate the different layers in a way that I've got a lamp over here. That's what's on top to try to show a little bit better if I can. But what I did is I know that some of you don't have access to like a ruler. If you do have a ruler, great. You're going to want to do some measuring of the different layers as well as you can. But if you don't have a ruler, but you do have loose leaf paper, which I imagine is the case for almost everyone, then you can use that loose leaf paper to make measurements. And so that's what I'm providing you on here, is how to use that loose leaf paper to make measurements. And so you could use your college ruled paper and you could just hold it up. Every line is 1/4 of an inch. All right, every 4 lines, that makes every 4 lines 1 inch, every 2 lines is 1/2 an inch. If you have wide ruled paper, then same idea, except every line is 1/3 of an inch, which is kind of an awkward measurement, but it's a measurement and it'll help you actually calculate these percentages. So it doesn't really matter that it's just 1/3 of an inch. And then you've got graph paper, right? And if you have 1/4 inch graph paper, it'll look like this. You may also have centimeter graph paper, which, or even 1/2 centimeter graph paper. Graph paper does vary, so don't just believe that it's all going to be a 1/2 inch. But here's the other thing, is that ultimately, as long as you're using the same measurement scheme, it doesn't matter what the actual units are, as long as you use the same units throughout. So if you just get some graph paper and you go, okay, you know, this one is 1 square and this layer is 2 squares and this last layer is 4 squares, then it doesn't matter. I just wanted you to be able to have some sort of basis in reality so that you just weren't saying 1 square, so that you were saying like 1/2 inch, 1/4 inch, whatever. But ultimately, you're turning it into a percentage which doesn't have any units, and so it doesn't matter.
To be clear, if we were in class right now, I would be a total jerk about everyone using the metric system, right? Like we would be like, you better be measuring in centimeters or millimeters. And I would be totally on you guys about that. But I hope that, yeah, I hope it's clear what Mr. Dutton just said. Like at this point, do what you can, measure it the way that you can. And like you said, once you convert it to a percentage, anyways, the actual units don't matter in the end. So yeah, please don't stress about that detail right now.
Okay, so, whoops, the next step here is actually measuring each layer. So I made a close-up of this one right here. It's not quite in focus. Let me see. Ah! My jury rigs.
Well, the picture that you have up is pretty clear.
Yeah.
It's alive.
Got the multimedia going on here. All right. So then I see here 4 layers. So let's try to identify what these 4 layers are. And hint, you're not going to use one of the layers in your calculations. So unmute yourself or answer in the chat what from top to bottom, what do you think these 4 layers are? Yeah, remember I mixed the soil 50% with water. Like 50% of the mixture is water. So which one is the water layer? So you're saying this one is the water layer? Ah, there we go. So this layer right here is water. Good. So then we have, in some order, sand, clay, and silt. So So let's think about the relative sizes of each particle. So sorry, I'm in the middle about three things. The largest particles would be gravel. Excellent. We avoided having large particles in here. So what would be the next largest among sand, clay, and silt? So if you go back to the Nearpod, you'll notice that clay is super, super, super tiny. We can't, with the naked eye, we cannot actually see clay particles. It just appears to be smooth. All right. And so because those are the smallest particles, they actually end up on top. All right. So the clay layer is going to be the topmost layer. They're the smallest particles. And they settle near the top. The medium particles, so what would be the next biggest? So if clay is the smallest, what would be the next biggest? Or intermediate, in between? So when we go to the beach, not when we're socially distancing, but when we go to the beach in general, we can see sand particles. We can see those pieces of sand, right? They're really easy to see. But if you look, there we go. If you look at the bottom of a riverbed or something, then you see silt. And you can actually, you can rub silt in between your fingers, and you can look closely and you can actually see each individual particle of silt. But it really takes you rubbing it in between your fingers to separate them, because silt particles like to trap water in between, but they don't hold on to the water like clay does. And that's really the biggest difference between clay and silt, is clay is so small that it actually helps to trap water. And it holds water really tightly, which is why you can ball clay up and you can make things out of it. I mean, you know, in art, you can make things out of clay, right? And that's clay. That's clay. It's not just like, you know, science-y clay. It's the same thing. So it traps water and you're able to shape it. Silt traps water as well, but it doesn't hold on to it. So water has a difficult time passing through silt, but you can easily remove silt from water. Whereas sand, water just passes right through sand. And obviously it passes right through gravel. And so that's where we get the last one, right? Which is sand. So there's a couple of ways that we can proceed from here. We can use, you know, our ruler, we can use our graph paper, we can use our line paper, and we can determine, you know, how many lines or how many fractions of a line or how many squares or how many fractions of a square, how many inches. and then determine percentages. And we'll work through those calculations in just a minute here. Okay. Let's also just start with an estimate. Okay, so about what percentage, and we're only going to consider, and this is really important, we're only going to consider from the top of the clay to the bottom of the sand. We're not going to concern ourselves with the water. The water just separated out. About what percentage of this entire column here from clay to sand is made up of clay? About what percentage is silt, and about what percentage is sand?
I'm gonna guess like 5% for clay.
Okay. I might bump that up a little bit, but I think you're right around there. You could even take your finger and measure it. You can go, all right, about how much, if this is 5, then how many times would I see that? If this is 10%, how many times would I see that? Yeah, so somewhere around 5–10%, I think, is very reasonable. Well, I feel pitied. About what percentage would be silt?
Think about, does it look like it's more or less than half of the whole thing?
Yeah, good call.
We're talking about silt.
Yep.
60.
Love it. Can't say I disagree. And possibly even more generous than that, right? Maybe 60 to 70. I mean, it's a lot, right? So somewhere around 60. Great question, Ben. What if there's no clay? Then that would be 0%, and we can look back at the soil triangle. Yep. I have a sample. I'll show it on my laptop here. I have a sample, my old garden sample, and hopefully with the light you can see that the clay layer is super thin. All right, and that's an example of where the clay layer is less than 5%. I would put it at less than 5%. So 0% clay is totally plausible, like Mr. Tao said. Okay, so we've got about 60% silt, maybe even a little bit more than that, we're not sure. And then that means that sand has got to be somewhere between 20 and 30%, if we're doing the math, right? And that makes sense. If clay is 10%, this looks 2 to 3 times as big. All right. So let's just take 10, 60, and 30. And let's go to the soil triangle. Oh, that's a hot mess. All right, so if we've got 10 clay, and we've got 60 silt and 30 sand, where does that get us?
Silt loam.
Beautiful. That intersection point is right there. And here's something else that should help put your mind at ease, is that let's say that it was actually a higher percentage of silt, and let's say it was a smaller percentage of clay. So like 70 and closer to 0, and somewhere between 20 and 30 for sand. We see we're still in silt loam. That actually doesn't change the soil texture. And that's our ultimate goal about doing these percentages, is to find the soil texture. So you can be 100% confident that this is silt loam, even if you're not 100% confident about the percentages. I hope that makes sense. So that's for the area where I had the weeds. And then what we can do real quick is take a look at the area for the lawn. And it's a massively different soil texture for the lawn. And I'm not too confident about my results either for that. Trying to spotlight my video. So taking a close look at it, and I'm trying to get the light to shine through the water and not through the clay, and I'm not being too successful here. Well, that's just not helpful at all, is it? Let me see if I can backlight it, if that'll help at all. Backlighting in Zoom is usually no good, but in this case it might be.
Mr. Dutton, can I ask a question?
Absolutely.
If we only have like 1 or 2 layers, how do you determine which type of soil particles? If you don't have all 3, how do you know which ones you have?
So it all should add up to 100, right?
Yeah, but if one of them is 0%, how do you know which one is 0%?
Got it. Oh, great question. All right, I'm not having any luck showing what I can see. Let me see. Wow, that's worse. Okay. So we'll just go back to where I was because that was better. The clay layer is going to look very light brown. So the clay layer in the weeds is almost, it's very difficult to discriminate between the water layer, but you can see it when you move the water around. You can see the very thin clay layer at the top when you move the water around. It is a very light brown. Now, that doesn't mean that clay all around the world is going to be a light brown. It just happens that the minerals in the clay in Northeast Ohio happen to have very little iron. Iron is what makes things red. You may have, depending on where you took your soil from, you may have high iron soil, but typically a lot of the soil around here is not. And so it's less reddish and more black, more brownish. And so that's why you're going to see a very light brown versus a reddish brown. But the clay layer will be either light brown or reddish brown. Your silt layer is going to be darker. And it's also going to look very uniform. So if we go back to my picture, which demonstrates it a lot better than what I'm doing right now. So if we go to back to this picture, you see how fine texture the silt is. And that's what can help you determine the difference between silt and sand. Sand, you can actually see the particles. So you can see the little rocks, right? Whereas silt, you can't discriminate between them. It looks like a solid layer. Clay also looks like a solid layer, but it's lighter. It's going to be lighter in color. And typically for soils around here, it's going to be much thinner. It's possible that you have more clayey soil, but unlikely. So if you do have a clay layer, it's going to be on top, it's going to be thinner, and it's going to be lighter in color.
What would our research question be for the lab?
You want to ask something around the texture of local soils and how it changes based on where it's measured. So if you measured in a place that has a lot of grass, so I measured in my lawn, for example, versus a weedy area, this can help me answer the question about like what is the difference in soil textures between areas that have high amounts of plant growth versus low amounts of plant growth. You can ask a question about the slope of a particular area. For example, if you took soil from a hilly area versus a flat area, you could ask a question about proximity to a road. So roads get salted during the winter, and that salt goes into the soil and it affects the texture of the soil. So you could ask about what the effect is of local roads on the texture of soil. You could ask a very generic question, because if you ask a question, that's great. But you could ask a very generic question using my data, saying, what's the soil like in Shaker Heights versus Cleveland Heights versus wherever you are? And you could just say, what are the texture differences between these different places? It's not a great question, right? Because you see that there's diversity in soil textures just within my own yard. But you could ask that question and you could come to a reasonable answer. So all of those are very valid questions. And let's take a look. We got a few minutes left. Let's take a look at the actual questions themselves. So I suggested finding a hill and a yard. You can change this location to wherever you measured. You can change this one to be Mr. Dutton's soil. If you have a slope, you can just describe it. So if you collected soil on a hill, you could say, gentle slope. Gentle slope would be something like, like that kind of slope, right? Or even like this. If you start to talk about this kind of slope, well, that's a hill, all right? And then that's a steeper slope. And then a yard, maybe the yard is just flat. You do not have to fill out this column. That's just if slope is something that changed based upon your samples. The sample that I shared with you was flat. So if you want to compare that to a place that does have a steep slope, then just know that we'll call it Mr. Dutton's weeds. Just know that, yes, I'm still reading, Mr. Tout. I'm not going to taste my soil. If you only got one sample, compare it to mine. Okay, and so the local vegetation for mine, weeds, and it was actually mostly bare. If you see the picture that I showed you of that sample that I collected, there were very few weeds on there. It was just the occasional one. The sample color itself was dark. So when you're describing the sample color, use dark or light. Use brown, red, gray, black as descriptors. If you go through my presentation that I attached, you'll see that there are some samples that have spots of brown and some reddish to them. There are some that are more black than they are gray. So we're not expecting you to be like, you know, chartreuse or something crazy descriptive. Just be generally descriptive enough to be able to discriminate between them. So this was a dark brown, almost black sample. And then the soil type we determined was what, silty loam? Was that right, Mr. Tout? I forget now. Because it was 60 clay, 60 silt, 30 sand, yeah, silty loam, or silt loam. I think it should say silty loam. I don't know why it says silt loam. And which sample contains the most organic matter? Again, you can look at the pictures that I took in order to determine if yours contains more organic matter than mine does. Organic matter meaning plants, worms, anything else that was alive. The most large particles will typically be the one that has the most sand. So the one that I pulled had 30% sand. So if you had a higher percentage of sand, then you would say yours had more large particles. Compare the color for number 3 and say if that's what you expected. This is to help you identify the soil type. So you can calculate percentages or you can estimate percentages. You would calculate percentages by adding up the depth of the clay, silt, and sand, and then dividing each one. So if you wanted the percent of sand, you would take the depth of the sand. So if it was 2 centimeters divided by the depth of the soil, so if it was 10 centimeters total, you would then multiply that by 100. So 2 over 10 is 0.2 times 100 would get you 20%, for example. And that's how you can also calculate percentages if you're doing it that way. And if you're using inches, of course, same thing. Don't worry about number 4. This is really just to get you to think about what type you anticipated versus the type when you actually put it into numbers.
We do 2 divided by everything that all the information that we have.
So the whole height of the entire column. So if I had 4 inches of silt and then I had 4 inches of clay, then that's what this would look like. That 10 inches is the entire height of the column.
So we're dividing it by how big our container is. How the layer by how big our container is.
Now that would be the height from the top of the clay to the bottom of the sand. This
That would be the 4 or the.
the 10. The 4 would be like if this measured 4 centimeters, then that would be 4 centimeters for sand over 10 centimeters total.
Okay.
Okay. Have a wonderful weekend. Stay safe and stay healthy. Enjoy the warming weather. And we will see you on Monday.
That's funny.
How's it going, Victor?
Good.
Mr. Dutton, sorry, I was answering your questions, but I did not realize that I was muted. So when you were asking the questions towards the end, I was like, yeah, and then I was, yeah.
That's funny.
Oh well. I tried. This has been a rough morning, technologically speaking, for me.
Yeah, that's what it sounds like.
But we're up and running. It's good.
So do you have chemistry today at 11:30?
Yeah.
I just say that because I got invited to a district meeting at 12.
Okay.
Maybe I'll ask Ms. Welch to see if she can also be on that because I have physics. So
Oof. Okay. I mean, I can join at 12:30, although I guess you can too.
Right.
So.
yeah. Good morning, Milo. Good morning, Julio.
Yeah, Ayana, you guys are gonna have to teach me CS because I know very little. Have you guys learned DOS? I can do DOS.
Ooh. We were just talking about deep cuts.
That's a throwback. Oh, I do have a question, and this can be for any of you. I'm trying to connect with my cousin because he's sort of quarantined on his own. He and I were talking about trying to do some online games together, but he's all Linux. Like he does everything in Linux. So how hard would it be for me to learn Linux if I have some background in DOS? Like, do you think I'd be able to pick it up quickly enough to like play some online games or is it going to be like, yeah, that'll take you 3 months to out? Does anyone here speak Linux?
I don't think so. Well, but I don't think the youngsters do. It is an adjustment.
I've heard of Linux, so
There we go.
Okay.
but I don't know it.
Thank you,
You're
Eunice avoids it. All right, that's good to know. Thank you, Eunice.
Like, I don't know. Find a YouTube video. I don't know.
Linux has decent GUIs, decent window managers,
Okay.
where you can make it feel a lot like Windows, but ultimately it is like DOS, like it's text-based.
Okay.
I would say that your DOS background allows you to feel comfortable going, oh, I type a command and it tells me something in return. And the file structure, navigation file structure is similar. But then after that, it can feel like a pretty steep learning curve.
Okay.
You can do it. it's gonna take some doing. Man pages are your best friend. Man stands for manual, but whenever you're like, ooh, that's a fun command, I have no idea what that does, then you get the man page for it by typing man space whatever the command is. And the manual page actually does a really good job at leading you through what the particular command does.
Cool beans.
All right, cool. All right, I'm going to stop pestering Milo and Ayana, and I'm going to get out of your hair. Have fun, guys.
You too, Mr. Tao.
Remember, I pity the fool who doesn't do their homework.
I like how you're like slowly leaving.
It's like this creep.
I'm literally falling off my chair trying to get off my screen. All right, see you guys.
Bye, Tao.
Okay. So Ayana, you're more than welcome to stick around, but this is
Why do okay, I keep on forgetting this. So yeah, I'll leave and I'll work on Fibonacci.
Yeah, good call.
Have a good day. I'll email you or chat. I don't know.
All right, sounds good.
Have a good day.
Have a good one.
Oh.